Yeah, children. So coming to Newton's law, some questions will be children today. Newton's law, some previous year questions. Previous year questions will be children. First question. First question. Define momentum and what is its units? Who will define momentum?
Sir, momentum is the product of mass and velocity.
Product of mass and
Velocity.
product of
And
mass and
units are kg meter per second
no one
square.
is saying except Vivek, no one is saying. So what are its units children? Kg and meter per second. This is kg, this is meter per second. Momentum is product of mass and velocity. Its units are kg meter per second. Its units are kg meter per second. Second question. How much momentum will an object of mass 10 kg will if it falls from a height of 5 meters? I'm sorry. What is the momentum? What is the momentum, children? A body is falling from height 5 meters, and on falling to the ground, what is its momentum? On falling to the ground, what is its momentum? Means we should find velocity while hitting the ground, children. First, you have to find out velocity while hitting the ground. What is its velocity while hitting the ground? Children, v square minus u square is equal to 2as. All of you know that. Because it is a freely falling body, 2 into 10 into 5. So v square is equal to 100. So v square is equal to 10 square. So 10 meter per second. Children. Velocity while hitting the ground is 10. Momentum while hitting the ground?
Sir, 100 kg meters.
100 kg meter per second. Momentum while hitting the ground is 100 kg meter per second. Children, how did I find out velocity while hitting the ground? V is equal to root 2gh. Derivation also showed. V is equal to root h. Explain how a karate player can break a pile of tiles with a single blow on his hand. Children, karate player, he will keep some plates here, and with single blow he will break all of them. How? Can anyone tell? Can anyone tell? Children, by increasing the momentum, children, by increasing the momentum. Children, momentum is equal to product of mass and velocity. Okay, entire he will increase the velocity and he will increase the and because of the momentum of his hand at a single point, at a correct single point in the center only he should be. Somewhere else if it will not break, children. So by increasing the momentum, momentum is equal to mass into velocity. Increase the velocity of your hand and mass of your hand. Okay, means but when you are increasing when you are hitting it with velocity, the momentum will increase, and that momentum is transferred to this pile at the center, and it will break at one point. Okay, this is one question. Previous year it is asked. Previous year questions. Second question. Second question, children. First time. Define inertia. Can anyone define inertia? What is inertia? Inability of body. Inability of body to change state of rest, motion, or direction on its own. On its own. Inability of body to change the state of rest, motion, or direction on its own, children. On its own. Okay. So second one. A shopkeeper shows three toys to a child made up of aluminium, steel, and wood. Three toys are mentioned. One is made up of aluminium, other one is made up of steel, other one is made up of wood. Three toys of same shape and volume. Which one of them would have highest inertia? Why? Among aluminium, steel, and wood, which will have more inertia?
Aluminium, sir.
No, aluminum is the lightest metal. Aluminum will not have. Aluminum is the lightest. Wood is also lightest. Steel will have maximum inertia. Why means inertia is the measure of mass. Inertia is measure of mass. Aluminum is lightest metal. That's why it is used in aeroplane parts. Also, aluminum is used. Of course, wood will have wood pores, children. So steel will have highest inertia because inertia is the measure of mass. Describe in brief an activity to illustrate the property of inertia at rest. For inertia at rest, any example you will give, children? Inertia at rest. Take a glass of water. Take a glass of water. Put a cardboard and put a coin here. Suddenly slip the cardboard, suddenly take out the cardboard. This, due to inertia thrust, falls in the water. Suddenly you should take, slowly you should not take. If you take suddenly, this ball will roll down and it will fall into the water because of inertia thrust. Activity means you should write on your own children. Okay, this is one question. Like this, we'll do some more questions, children. Like this questions, application directly they'll ask in exam, children. Third question. State Newton's second law. Anyone?
Sir, rate of change in momentum is directly proportional to the force applied.
Very good. Rate of change of momentum. Very good. Rate of change of momentum is directly proportional to force applied. Directly proportional to force applied. Very good. Can anyone define? Any other student? Can any other student define Newton's second law? Can any other student define Newton's second law? Shanmugh, define Newton's second law. Hansika, define Newton's second law. Hansika. Show the first law of motion can be mathematically stated from mathematical expression from second law. Okay, Tanmay, can you define Newton's second law? Tanmay, Srihita, Neeraj, it's there on the board. See and tell. Vikram,
Sir, Newton's second law, sir.
yeah, it's there on the board. See and tell.
Rate of change of momentum is directly proportional to the force applied.
Yeah, thank you. Show that first law of motion can be mathematically stated from the mathematical expression for the second law of motion. He's saying, children, second law is F is equal to ma. From F is equal to ma, can you say Newton's first law is asking children? F is equal to ma is the second law. F is equal to ma is the second law. Children, F is equal to m into v minus u by t. So we can say here, children, every body continues to be in a state of rest or motion or direction until and unless external force is applied. Every body continues to be in a state of rest or motion or direction until and unless external force is applied. So next one, children. A stone is dropped from window, reaches the ground in 0.5 seconds. Stone dropped will reach the 0.5 seconds. Okay. When it is dropped from the window, it is reaching the ground in 0.5 seconds. G is equal to 10 meter per second square they have given. Calculate the speed before hitting the ground. What is the speed while hitting the ground? So children, normally I did v square minus u square is equal to 2as. V square minus 0 square is equal to 2gh. Okay. Because time is given, v is equal to u plus at. Because it is falling freely, v is equal to 0 plus gt. So v is equal to 0.5 into 10. So v is equal to 5 meters per second it hits. It hits the ground with 5 meters per second, children. Why I took u0, children? Because it is a freely falling body, children. Next, fourth question. Name the property of bodies to resist a change in their velocity. Anyone? What is the property to change, resist the change in velocity? Inertia of motion. Inertia of motion is the resistance to change in velocity. What is the relationship between force and acceleration? He is asking. F is equal to ma. Third question, children. What name is given to the product of mass and velocity?
Momentum, sir.
Momentum. Next one, children. Which physical quantity corresponds to the rate of change of momentum? Which physical quantity?
Force, sir.
Force. Force is equal to rate of change of momentum. Force is equal to rate of... Name the principle on which rocket works.
Sir, it is third law.
Newton's third law. Rocket works on Newton's third law principle. Fifth question, children. State the law that provides the formula for measuring force and definition of force. Which law gives the definition of force, children?
Sir, second law.
Newton's second law. What
Second law, sir.
Newton's second law states that rate of
Change in momentum is directly proportional to the force applied.
force applied. Okay, so next question. They have given a graph here. See, children. They have given a graph here. It is there like this. Children, this is velocity, this is time. This is the, okay. They have given a graph like this, children. And the mass of the body is 50 grams. Mass of the body is 50 grams. Maximum velocity is 30 in 25 seconds. This is the question, children. So, what is the question means? In how much time does it stop? Question is in how much time does it stop? Which was there 30.
Sir, in
After
25 seconds.
yeah, in 25 seconds it is stopping. In 25 seconds it is stopping. It is stopping after 25 seconds. After 25 seconds it is from 30 it is coming to 0. Next, what is the negative acceleration produced here? How much is the acceleration? V minus u by d. Where is v is how much, children? V is how much?
0,
0
sir.
minus 30 by 25. How much, children? Minus 30 by 25 is how much, children? 5 6 are 5 5 are 1.2 meter per second square. What is the force on it? What is the force? Force formula, anyone?
Sir, F is equal to ma 50 into 1.2.
Not 50, 50 by 1000.
Sorry,
Because
sir. Okay, it's in grams.
5 was 60, 60, 3 zeros down. So 0.06 Newton is the force acting on that body, children. 0.06 Newton is the force acting on that body, children. Next question. Next question. Children, all these are application type of questions, children. They are asking in Newton's laws. Next question. Why it is difficult to walk on sand? Anyone? Why it is difficult to walk on sand? Because in sand, children, in sand, what happens? Normally, if surface is flat, okay, if surface is flat, it will exert equal force on it. But since the surface is very smooth, since the surface is momentum increases, children, momentum increases. Our momentum, when we are walking, our momentum increases. That's why it becomes difficult for us to stay because our legs will going into the sand and momentum increases, time of momentum increases, inertia increases. Therefore, it becomes difficult to walk in the sand. Why is recoil of heavy gun on firing not so strong as that of light gun? Children, recoiling of the gun, yesterday I told you, children, I have shown you so many. So mg vg plus mb vb, I told you just recoil. Okay, recoiling gun formula, children. This goes here minus mb vb by mg. Okay, children. If gun is heavy, then recoiling will be less. If gun is low in mass, then recoiling velocity is high. You have to show like this, children. Because these both are inversely proportional. No? Velocity is inversely proportional to mass. More is the mass, less is the recoil. And if less is the mass, more will be the recoil. You have to show with like that, children. Okay, next question. A constant force acts on an object of 5 kg. Children, a body of 5 kg is there. A constant force is acting for 2 seconds. It increases the velocity from 3 to 7 meters per second. What is the force applied? Children, anyone? What is the force applied? Yes, children, anyone? Force MA M into V minus U
Sir,
by
10, sir.
so y into 7 minus 3, 7 minus 3 by 2. Our children 5 is equal to 4 by 2 is 2. That is 10 Newton is the answer. So children M into A is equal to V minus U by T. This is V, this is U, this is T, children. Okay. Next. Last question, children. Last question for the day, children. They have given a graph. Children, see here, graph is like this, like this, like this. Okay. This is speed graph. Maximum speed attained is 20 G. Maximum speed attained is 20. 0. This time is 4. This time is 6. This time is 8. This time is 10. First question. 1000 kg car. This is 1000 kg car. First question. What is the maximum force acting on the car? What is the maximum force? Maximum force it acts from here to here. Because it is
20.
acceleration, this is retardation. F is equal to m into v minus u by t. Mass is how much, children? Mass is how much?
1000 kgs.
1000.
V is how much, children? Final velocity? 20.
Sir,
Minus 0.
20.
In 4 seconds, children. So 1000 into 20 by 4 is 5. That is 5000 Newton is acting maximum force, children. Maximum force. Let's find here also, children. Here. F is equal to m into b minus u by d. 1000 into here final velocity is how much? Final velocity?
sir, 10, sir.
0.
0,
Final
sir.
Initial velocity is how much?
2, 20, sir.
By in time how much? 2 seconds.
2 seconds.
20 by 2 is 10. 10 into 100, 10,000 Newton. This is the maximum force applied. This is the maximum force. Here means here maximum. To stop the car, they are applying more force than to start the car. Second question. This is accelerating force. This is retarding force. Third question. How long was no force acting on the car? How long?
Sir, 4 seconds.
Yeah, for 4 seconds it is traveling with constant speed, so no force. For 4 seconds there is no force, directly it is traveling with constant. Find out acceleration of the car during which the first two intervals of 4 seconds each. Find the acceleration of the car during each of first two intervals of 4 seconds each. Here what is the acceleration, children? Here what is the acceleration?
Sir, 5, sir.
Yeah, 20 minus 0 by 4, that is 5 meters per second square. Here what is the acceleration, children? Here
0, sir.
0 acceleration. Here what is the acceleration, children?
Sir, minus 5.
Minus 10.
Minus 5.
Minus 20 by 2, that is minus 10 meter per second square. Children, 0 minus 20 by 2 seconds, so minus 10, children. Here is minus 10, here is 5, here there is no acceleration. Here there is no acceleration. Like that, some of the questions we'll do tomorrow in motion and Newton's laws, children. So like this, different questions will be coming. If you know the lesson only, you will be in a position to answer like these questions. You have to practice textbook and so many other reference books, 1 2 reference books, and you have to practice, and all these sums which I'm saying, you have to practice, children. Then only you become perfect. That if not, it will become difficult for you to answer in the exam, children. Thank you.